All right, here we go. We've got another example right here. This one's a little bit more difficult because they don't just tell you what the height is. You have to actually figure out the height. So they do ask for the area. I believe that's all they ask for. Yes. They just ask for the area. And I don't know why my pen turned to an X, but it still works. Me too. All right, so we're trying to find the area of this thing. Well, what's the area of a parallelogram? It's the base times the height. Well, do we know one of those? We know the base, don't we? All right, so the base, let's just do this. The base is 15. All I have to do now is find what? The height, okay? I'll just leave it blank right there. So we got to figure out what the height is. Daniel, what do you see? Yeah, that's right. It's 45, 45. Doesn't exactly look like one. This is not drawn to scale. Okay, but if this is 45, you're absolutely right. This would be 45 as well. Okay, that's perpendicular because that's the height of it right there. How does that help you? Yeah, you could do 45, 45 if you wanted to, or you could just do a trig function. Tell you what, just for fun, let's do the trig function stuff, okay? Because we just finished doing that, didn't we? So let's do the trig stuff. So actually, we just did circles, right? It was the chapter before that we did the trig stuff. So if this is 45 and we want to find h, what would we use? This is the sine, right? It's opposite over hypotenuse. So let's go the sine of 45 equals the opposite h over the hypotenuse, 8.5. Now we solve for h, so we just multiply both sides by 8.5, and we just chuck that in a calculator. And let's see what we get. Just happen to have a calculator right here. Oh, lots of junk on there. All right, so it's 8.5, sine 45, sine of 45. And it's about 6, right? You got 7? Are you in radians or degrees? You don't know how to find it? So what did I say it was about 6 point something? 6.01. 6.01? Yeah, we'll just say 6, okay? This was in millimeters. I didn't show it here, so it's just 6 millimeters. That's not our answer, though, is it? I mean, why did we find that? Because we're trying to find the area. So what do I do right here? Just put a 6 in there. Remember, it's approximately 6. It's not exactly 6. And what do we do to those two numbers? Just multiply them together. 6 times 15 is what? 4 is 60, and another 30 is 90, right? So it's 90. Now, it's in millimeters. What's my units? What are my units? It's millimeters squared, okay? I'll tell you right now, right off the bat, you listen? Right off the bat, I will not take off if you don't put the units correct, okay? Just because I'm just trying to teach you the geometry principle. I taught physics for a bunch of years in my other school, and when I taught physics, I definitely took off for the units, okay? Because that was really important. When you're doing real-life things like that, it was really important that you put the correct units. Here, I won't mark it off, but I'll still, when we do these examples, put the correct units. I would still like you to practice putting down the correct units. All right, just because I don't mark off doesn't mean you have to be lazy and not put them down. Okay, so I would really like to see you put them down, but I won't mark off if you don't, or if you do it incorrectly. The numbers were really what I'm looking for. You okay with that? All right, let's move on. All right, now we're going to take a look at a triangle, and you're looking at this and saying, well, that doesn't look like a triangle. I'm just showing you where we get this formula from. Now we know what the area of a rectangle is. It's just, oops, I made that into a line. There's the base, and there's the height, correct? Now, if I did this, watch this. If I took it from one corner and went like this, now, we can call that the height as well, can't we? This is a right triangle. Guess what we have here? What's all this stuff in here? That's just a what? That's a, what's this thing right here? Look what I'm... It's a triangle. Thank you very much. It's a triangle. All right, so look at it. The rectangle was just the base times the height. How much of this whole rectangle is this triangle right here? It's half of it, right? I went from point to point. I split it in half, didn't I? So what is the area now of a triangle? It's not just the base times the height. It's the base times the height, what? Divided by 2. Or you could write it as 1/2 the base times the height. Whatever you're more comfortable with. I really don't care. And they do it both ways in the book, okay? Either one. All right, so the area of You know what the T is for triangle, okay? The area of a triangle, base times height divided by 2, or 1/2 the base times the height. It's the same exact thing. That's where they get that 1/2 from. A lot of people don't understand where that half came from. It's really not that hard to see. Take a rectangle, split it in half. That triangle is half of the rectangle. So the rectangle is base times height. The triangle must be half of that. Everybody got that? Pretty simple. All right, so there's your formula. Know the formula. Have it memorized. You have to have it memorized. Let's do an example. Resume. Now we have a triangle, and we want to find the area of this triangle. Let's write some stuff down that we know about this triangle. And in fact, let's pause here a second. All right, look at this example. This example is a little bit different. So let's read it. It says the height of a triangle. Now, where is the height of the triangle? Let's draw it first before we even continue with anything. If that was the base of the triangle, then the height would be from here. I guess you could say straight down, but what would you really say? Perpendicular, right? Perpendicular, it's not an angle bisector. It's just perpendicular to the base, all right? So that's our height, and that's our base. So let's read it. It says the height of a triangle is 5 centimeters more than the base. Well, if the base is b, then the height is what? Is b plus 5. It's just 5 more than b, so it's b plus 5. You with me so far? Then it says the area of the triangle. This time they tell you. They don't ask you to find the area of the triangle. They tell you the area of the triangle. They say it's 52 square centimeters. They write the word out, square centimeters. I'm just going to write it like this. It's just a little bit handier, don't you think? It says find the base and the height. So we have to find the base and the height. So basically, if we find the base, b, then we can find the height very easily. So let's write down a formula. Area equals, let's just write it like this. I kind of like writing it like that, don't you? Instead of the 1/2 out in front. So it's the base times the height divided by 2. Well, what is the base of this thing? It's just b, isn't it? Times the height. What is the height? It's b plus 5. And what's the rest of my formula say to do to this? Divide it by 2. Now, a equals this, doesn't it? So what is the a? It's 52. Now let's clean it up. It looks a little ugly right now. So it's 52 equals, what can you do here? Yeah, you can go b squared plus 5b over 2. What do you do with this? Get rid of the 2, right? How do you get rid of the 2? Multiply it by 2. So you multiply that by 2 as well. What's that? 104 equals what? B squared plus 5b. This kind of looks like what now? Quadratic, yeah, the dreaded quadratic. We're going to do a ton of this next year, but let's do it again. Okay, we've talked a little bit about this year. I want to set this, it's an ugly b. I want to set this equal to 0, don't I? So let's move that 104 over, so you're going to subtract 104, and that equals 0. All right? And I'm sneaking a peek right here because I can't just think of that in my head. You could do quadratic formula, but I wouldn't because this thing does actually factor. It's 13 and 8. 13 times 8 works here. So it's positive 13 and it's negative 8. Don't worry about this right now. In Algebra 2, we'll do a ton of this. Some of you did it in Algebra 1. That's great. If you didn't, we'll definitely do it next year in Algebra 2. So, look. 13 times negative 8 is negative 104. You with me? It's just kind of like backwards FOIL method is all it is. And then if I add them together, positive 13 plus negative 8 is what? Positive 5. So that does factor real nice, doesn't it? And now what do? You got these two things being multiplied and they equal 0. Do you remember what our next step is here? Say it. No. Set them equal to 0. That's right. Set them equal to 0. And again, next year we'll talk a whole bunch about that in Algebra 2. Set them equal to 0, so b is what? Negative 13, and b is 8. Now, how in the world can b be equal to two different numbers? Well, get rid of the negative. Very good. There's no way it's negative 13. You can't have a length of anything being negative, can you? So you only pick the positive. So b is 8. So the base is 8, and what's the height? It's 13. Daniel? It's a good question. I've thought about that, and I can't exactly answer that right now. There could be, but I really doubt you'll see one though. Okay, I can't think of one at the top of my head or anything, but I don't believe they'll ever do that here. I really don't. All right. Did I try to circle that 8, or did I put that 8 after I circled it? Because that was a pretty bad circle if I tried to include that 8.
Eight.
All right. Okay. Let me just take a quick peek, see if there's anything else. Nope, that takes us to the end of it. Let's put down say this on here. All right, so there it is. This is obviously section 11.1. There's page numbers 10 to 22. There's a little gap in there. Then you jump to 30, do 30, 31, and 32. All right, go ahead, Matt.
Tangent, quid!